Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 5 of 2014 JEE Advanced Physics Paper 1. Students, let us solve question number 5, which says let E1R, E1 is the electric field as a function of distance R, E2R, E3R be the respective electric fields at a distance R from a point charge Q. An infinitely long wire with constant linear charge density lambda coulomb per meter and an infinite plane uniform surface charge density, infinite plane uniform charge density sigma coulomb per meter square. If E1 R0 is same as E2 R0, R0 is any given distance, and E3 R0 are same at a given distance R0, then which of these options are correct? Basically it is a formula based question. So first of all, we have got three different situations. One is a point charge Q. So from this point charge Q, at a distance of R0, my electric field will be E1 of R0. The formula for that, for a point charge, we all know it is kq upon r square. So it is kq upon this distance square, which is k is 1 upon 4 pi epsilon naught, that is k q upon r naught square. This is equation number 1. Similarly, I'll go for the next object, that is a long, infinitely long wire. For a infinitely long wire of lambda coulomb per meter, the charge will be distributed. It is like a cylinder. So wire is like a cylinder, and at a distance of again the same distance R0, the electric field E2 of R0 as a function of R0, as a distance R0, at distance R0 is given by, we know the formula for that, that is lambda upon 2 pi epsilon r. Lambda upon 2 pi epsilon naught r, r is r naught. This is equation number 2. Similarly, we will have a plane. This is a plane sheet, the plane sheet of charge that I have given, plus the charge is given is charge density. Here this must be in coulomb per meter, and this must be for coulomb per meter square. The charge density of this plane is a plane sheet at the same distance R0. At the same distance R0, the electric field is E3 R0, which is given by, we have already known that near this R0 should be very nearby point. Obviously it should not be very far off. So if I have a plane sheet, infinite plane sheet, and nearby if I take a point at a distance R0, then the electric field is uniform at any R0 place, because that is infinite and that is constant, that is sigma upon 2 epsilon naught. That is sigma upon 2 epsilon naught, that I'll put here sigma because it is a sheet. So sigma upon 2 epsilon naught. That derivation is already there, 2 epsilon naught. If you forget how this comes, I'll just go for the little derivation of that. Then we'll see, then we'll go for the expressions. And let us see how this comes by Gauss theorem. Let me just derive the formula for you. If you have a plane, infinitely plane sheet of plane sheet of metal, then I give a charge density sigma, then I have to consider this goes on like that. I will consider nearby distance. I will consider a small area here, ds area, and I allow this, I will consider a Gaussian surface. I will consider Gaussian surface like so, and this will penetrate and goes out of the other side of this plane sheet. That means this is a plane sheet. I consider a cylindrical surface area like that. This is a cylindrical surface area. This goes into this and comes out of that side. That we have already done. That we have done this. Now this area is ds, and this area is obviously ds, and according to Gauss theorem, the Gauss theorem says that the total electric flux, the total flux phi total is charge enclosed within that Gaussian surface divided by epsilon naught. That is the total flux. Then the total flux coming out of this, I will write the formula for flux is E ds cos of theta, E ds cos theta integration over the closed surface, and that gives me q enclosed upon epsilon naught. If this area is ds, then the charge, because of this charge density, the charge which is present over here, and the charge is present here, and which is inside the surface, Gaussian surface, will be sigma into ds divided by the epsilon factor. Now to find this, to solve this expression is solved. To solve the left hand side of the expression, we have a cylindrical surface like that. So this end is flat, this end is flat, this is a curved surface. So, and the sheet goes like that. So if the sheet is like that and charge is distributed like this, then for these curved surfaces the electric field will be like that, and for this flat surface the electric field will be perpendicular to the area, and for this is parallel to the area. So the area vector is like that, and the electric field is like this. So E dot ds cos theta cos 90 is 0. So for this particular curved surface, the area vector is pointing up, this is upward, and the electric field vector goes like that. So the angle is 90 degree. So there is no flux contribution by the curved part of the Gaussian surface. So if I don't take into account that, then I will consider only for these two surfaces. So there is no flux contribution from the cross surface, only we are left with two flat end of the surface, this flat end and this flat end. Here the electric field is like so, and the ds vector, area vector, is like this. Here also electric field vector is like that, and area vector is like that. So this area is ds, this area is also ds, this area is also ds. The angle is 0, and therefore if I divide this into three parts, 1, 2 and 3, so integration of eds, these two are added together, cos of 0 for this surface 1, flat 1, 1 plus integration of eds cos of 0 for that second surface, this flat end 2, and the curved one gives me 0. That total gives me sigma ds upon epsilon naught. Now this cos 0 is 1, this cos 0 is 1, so eds I have the electric field is same, that comes out, and the total area integration of ds, the total area itself is ds. So if you solve that, then you will get eds. Here also you will get eds, and that it gives you sigma ds upon epsilon naught. That ds factor will cancel out. This is 2e, so from here I am getting 2e equals to sigma upon epsilon naught, and e comes out to be sigma upon 2 epsilon naught. So this expression I wrote without any derivation, because you have to remember, as you are appearing for JEE Advanced, this formula are to be remembered always. This sigma upon 2 epsilon naught that I put here actually is derived like that. You have to remember the result. So let us proceed. Similarly, you can derive the expression for this also and that also, that all things you have to remember. I am not going to derive this expression because it is not required for JEE Advanced. You must remember this. Now coming back to the question, we have to check this question that Q is 4 sigma pi r naught square, whether it is true or not true. So first option we'll try and see the option number 1, and we'll check the option whether it is correct or wrong. The option number 1, I'm just writing it down. Q is given as 4 sigma pi r naught square. Okay, this is the statement. We have to see whether that is true or not. We should always have this information. To check this, basically it is a relation between Q and sigma. Q will obtain from this expression, and sigma will obtain from third expression. So that means you have to relate these two expressions. If because it is given that the E1, E2, E3 all are same, because it's given, so I will write that E1 not 0 and E3 not 0 are same. So I'll use equation 1 and equation 3 and solve, because given E1 R naught equals to E3 R naught, so I'll write the value of E1 R naught, which was 1 upon 4 pi epsilon naught, and Q upon R naught square. That already we have done. Next is for the right part, E3 R naught was, as I told you, it was sigma divided by 2 epsilon naught. Now you have to solve this and see whether we are getting this or not. This epsilon naught will cancel out. This Q will become, this 2 and this 2 will cancel out, becomes 2. So 2 pi sigma R naught square, 2 pi sigma R naught square is the answer. That means this should be the answer. but in the question it is given 4, but here we are getting 2. So option 1 is wrong. So the first option is wrong. It should be 2, not 4. Next we'll check the other option. Okay, we can use here option number 2. In option number 2 is given r naught equals to lambda upon 2 pi sigma. R naught equals to lambda upon 2 pi sigma. That we have to check. Okay. Now that means it is the relationship between lambda and sigma. Now where is lambda? Lambda is here, sigma is here. That means it is relating these two equations. Because these two equations are same given in the question, so you have to relate this with this. So because that is given, I will just directly write and check lambda upon 2 pi epsilon naught r naught equals to sigma upon 2 epsilon naught. If I see that, then epsilon naught cancels out, 2 cancels out. Our it is given in the question, you have to check this one, just like we have to check this one. So to check this one, I have to keep r naught out. If I keep r naught out from here to that side, this will be lambda upon pi sigma. That's all. This is the value I am getting, but here it is 2. So therefore this is right, but this option is wrong, because 2 is there. It should not be 2 because we are getting pi only. So option 2 is also wrong. This is also wrong. Let us see whether option 3 is correct. Option 3 we'll check now. Option 3 is given that E1 R naught by 2 equals to 2 times E2 R naught by 2. So to solve this, we'll proceed like that. E1 R naught by 2, I'll use another pen over here. E1 R naught by 2, but what is E1 R naught by 2? We know that in case of E1 R naught, that means this one, at a distance R naught by 2, if I come down to half of this distance, R naught by 2, then this point, this situation will change to R naught by 2 here, because I have to put R naught by 2 here. So this expression of E1 R naught by 2 will become E1 R naught by 2 will become 1 upon 4 pi epsilon naught q upon R naught square. It will become R naught by 2 whole square. This will, 4 will come here, and this will be R naught square, because R naught by 2 whole square, 4 will come up. Similarly, I have E2 R naught by 2, E2 R naught by 2. What is E2 R naught? E2 R naught is this one. So if I put R naught by 2 here, I have to put R naught by 2 here. So 2 will come up, this will cancel out. So this is lambda upon 2 pi epsilon naught. So this will become lambda upon 2 pi epsilon naught R naught, that is R naught divided by 2. 2 cancels out. So this becomes lambda upon pi epsilon naught R naught. So in all this, you have to only relate the equations and match it whether it is correct or not. So I'm just doing that. E1 is this, E2 is this. Now he says that I got this value, I got this value also. He says check whether this is equal to this. That means 2 times E2 of this value, 2 times E2 of R naught by 2. If I find, then I have to multiply 2 here. That will be 2 lambda divided by pi epsilon naught R naught. So this I am getting here, and it says that must be equal to this. Then I have to see whether these two are same or not same. Here I have already got this expression E1 R naught is this one, so this one is 4 times E1 R naught. So this becomes, I can write this as 4 times E1 R naught, and this one already I have got this as E2 R naught, so I have to multiply 2 and divide 2. So if I multiply 2 and divide 2 this expression, I'll get 4 lambda divided by 2 pi epsilon naught R naught. If I do that, this becomes E 4 times E2 R naught, because E2 R naught is this one, so I, in place of this I have written this. Why I am doing so by multiplying and dividing? Because we have to relate these two expressions. So to relate these two expressions, we already know that E1 R naught and U2 R naught are same. So if I compare this equation and this equation, which is finally giving me this, so from these two equations I am getting the right hand side as this and this as right hand side as this. Because now whether these two are the same or not, obviously same, because 4 E1 R naught and here I am getting 4 E2 R naught. Already it is given in the question that E1 R naught is same as E2 R naught. That means 4 equals to 4. That is correct. That means the option 3 is correct. So option 3 is the correct choice. Next, you have to check for this E2 and E3 options also. So we'll solve for E3 and E4 one. So I will just do that. For option number 4, we have the relation given E2 R naught by 2 equals to 4 times E3 R naught by 2. Whether this equation is correct or not, that also we have to check. And to do that, again E2 R naught by 2, you can see here E2 R naught is this one, E2 R naught by 2. I am directly writing this as lambda upon pi epsilon R naught. This is pi epsilon R naught, but 2 will cancel out. This equals to, I'm just checking it out whether they are coming out equal or not, that will see. 4 times, I'm assuming that they are equal, and whether they are equal or not, that will find it out. E3 R naught by 2. E3 R naught is this, but then we must know that at a certain distance, whether it is R naught or it is R naught by 2, the electric field due to a plane charge is independent of this distance. This is very, very important conclusion. So for whether R naught or R naught by 2 or R naught by 3, this will remain the same. So therefore, this will be sigma divided by 2 epsilon naught. That will not going to change. So now, if I write this, because I know that E2 R naught is same as E3 R naught. So to relate this, to cancel this, I will write this expression in terms of R naught, this expression in terms of E3 R naught. To do that, for E2 R naught, I need lambda divided by 2 of this. So 2 is not there, so I will multiply 2 and divide 2. There is nothing going to change in this expression. This becomes E2 R naught, and from here this is 4 times sigma upon 2 epsilon naught. Sigma upon 2 epsilon naught is E3 R naught. So I can directly write in place of this E3 R naught, E3 R naught. So if I do that, then we know that they are equal. This is given in the question, so they are equal, they will cancel out. If I cancel out, I get 2 equals to 4, but 2 can never equal to 4, so this answer is wrong. So not possible. Not possible. So option number 4 is wrong. So in this expression, if I see option number 4, it is not right, it's wrong. So in this question number 5, only answer that is correct is option number 3. Okay, thank you.